Yeah, that's, is it on? Yeah. That's a mouthful. So if you see me a bit awkward, I usually walk, but I don't try to cut across the screen. So sorry for that if you feel me a bit anxious. So this is about scaling, one of my past clients where we actually had a big ball of mud. And I'm going to explain a bit later what it is. But this was a product that was built over 2 years, by a team of 3. And it was to get a new, product out in the market, to see if it works, get the market fit. So, they used capabilities in the same architecture that they're already using which was also legacy software as well. Sound familiar to anyone? Anyone ever worked in these companies before, in systems? Yeah. So, as you see here, it's written with MVC, which I call mid-code. So it's not particular low code yet, but it's easy to get something live with an MVC. It's based on the previous models. So this is what usually happens, right? You get a market fit. There's already previous software models there. You tend to copy paste that to the new model. They use both the website and custom ERP that's already there and the SaaS. So they tried to merge the custom ERP into the SaaS ERP, which didn't really fully migrated yet. Anyone had that problem? Yeah, also. So I think this is a lot of companies I go through, and I'm a bit biased. So potentially they're building useful capability. It's a little bit promising. They scaled up from 3 to 30 engineers when I arrived there, and they needed to keep delivering features. So who's been in this situation before, where you had a product fit and need to scale, but now it's actually holding you back? So this is what I do. I help customers. I'm an install consultant, as already mentioned, to catalyze organization and teams towards designing and building these software architecture. I'm also a policy value practitioner, so I help companies implement, use team topology as a framework for fast flow. And I also, this client case I was talking about is actually a use case in architecture and modernization. And this is what this talk is about. So I'm going to talk, already mentioned a bit about how numerical design helped in this, why understanding the underlying needs of the user was crucial, and how we can embed software architecture in teams. And that's a very important part of my talk today. But first, let's look at the MVC framework. So this is the MVC framework they used with, and it's very important for the story because it is designed to make programming web applications easier, but also with ease. And I'm seeing that in low-code programming nowadays as well, which I help. It's also easier to make a mess. Because what usually happens in this situation is they're building a huge model, right? It's called model view controller for a reason. They build one model. They just keep adding features to it until it ends up here. By the way, this is not only with MVC a problem. This is also a problem with your ORM frameworks in Java and C#. And it will definitely be a problem with low code in 3 to 5 years when maybe sooner because you can move fast low code. So fast to create these things. So that's a problem, right? This is what we call a big ball of mud. Why? Because if you scale from 3 to 12 people, who owns what? How can you split the team? This is what a lot of companies are dealing with now, right? Yes, we want to work agile. We want to have DevOps to be autonomous, but how? We have this thing. And this is built in 2 years, right? This is not really the legacy I work with. I also work with legacy which was built in 50 years. Can imagine how huge that is. So this was actually a book written 25 years ago by Eric Evans who had the same problem already. And I'm not going to give a long talk about this, but the essence here is that he had 2 teams working on one application. And one team was going very fast. The other team was holding the other team back because they were building in this one big software block. And this monolithic architecture got a bit tainted by it because people were building monoliths in my opinion, the incorrect way. They wasn't using software design because a monolith has modules, should have modules in them. And a lot of them is not built with this. If you build a proper monolith, also 20, 30 years back, it is scalable. It is easily just scalable. But a lot of people didn't do it, so now they call it a modular monolith, which is like, a monolith is modular by default, in my opinion. But the problem, what I see people using nowadays, using EDD, is that they look for oversimplified entity relationship models based on reality. So they're going to split the monolith up in a user service, in a product service, in a transaction service. Sound familiar? Yeah, so we're using this down to split it up. And this is actually making more of a mess. And I'm going to tell you a bit why. So it's good to start that way, but eventually you want to split it. And this is the hard part about domain-driven design. Because this is actually an edge pattern. This is what Barry calls platonic thinking. He actually calls Plato a bit evil because we're really busy with the object and the things inside the problem. Rather than what we try in DDD is to look for these proper bounded contexts, which are about purpose. And every time I give training as well in DDD, I'm gonna rephrase this a lot, purpose. And it's a linguistic boundary. So it doesn't actually have anything to do with how the software is actually being deployed. It has anything to do with how we talk about it. Saying this, if I go to Germany, I should really watch what I'm using as words, because words are ambiguous. I have a friend from Flanders, and I went to Vlaanderen, and it's Dutch. Well, some words are not. So we get confused a lot sometimes. We're just watching, do you need to say? No, we don't. And this is one of the major properties in context. So the thing about the first part is for each specific problem, we want a specific model. And it's the same as you open a book with a lot of maps. Each map solves a different problem. The map we all know, which is the Mercator map, where Greenland and Africa are the same size. It's really nice. Is actually the purpose was to cross the ocean. You can draw a line on that map, and you can get to the point where it is. Now, why am I telling this story? And this is actually a story about Eric Evans, is that if you want to know the correct size, you pick a different map. And this is not how we do it usually in software design. We say, hey, we have this model, it has countries, it already has sizes. Oh, can you also put the correct size in? Of course we can. We're ITers. Let's just write a couple of exceptions in our model. Done. Right? But at some point when that scales, it doesn't have clear boundaries anymore. Stakeholders will compete with each other because a stakeholder comes in, hey, can you optimize this Mercator projection? Yeah, I just need to talk with the other stakeholder here. And now things get weird. So for each model, for each purpose, you get a different model. And there's a lot of confusion here, but what you can do from this big ball of mud, you can actually find these specific models here. You dissect them. There's a lot of confusion about bounded context, but there's actually not. Domain-driven design allows you to break down your domains into smaller models, enable a single team to take ownership. That's the true purpose of domain-driven design. Right? It's about teams and it's about software models. It's not about microservices. It enables microservices, but it doesn't have anything to do with it. This way empowers teams to make changes more independently, because if I'm independent enough to change the Mercator map, for instance, and another team is for the other map, we're not in each other's way, because size is very ambiguous in these two models. Yeah? So this was really a key thing in this team to keep the shop open. We started extracting bounded context. And here's the thing, we did it guided by the roadmap. So we looked at the roadmap, we look what's the coming years, and where can we find a bounded context that we touch on that backlog, so sort of like a purpose that we touch on the backlog, and what is something which is hard to do with the current model, right? But not hard, not really complex, so you want to be in the middle because you want to experiment. So, to wrap this part up, DDD is really a discipline rooted in the belief that creating good software comes from knowing the problem. And I'm going to dive a bit more into this because there's a lot of confusion about that as well. And a lot of teams don't get access to the real problems of the users they're building it for. And this is a big problem with implementing domain-driven design. I've helped a lot of teams doing this, and it has a lot of potential. But if you don't actually let the team know what are the underlying needs of the users, then they cannot design these bounded contexts, these software models correctly. And then you actually make it worse. And then in the end, who's to blame? Domain-driven design. Or last time it was microservices or another framework, just call it that way, right? So it's very important to understand the underlying needs of the user. So what we call in domain-driven design, the team needs to become domain experts. They need to understand what problems are my users actually facing. 12 years ago or 13 years ago, I started at an asset management firm, and the first thing they did, they sent me to a 2-day course on asset management because they wanted me to understand what the users were actually facing with. I've met other companies, and we don't give workshops to engineers in the business, and but they need to understand to build this software. Because if you look now at, and this is a Wortley map for the ones, or this is a value chain for the one who's recognizing it. If you look at like a student and a recruiter find the best job for a student, work a single day, and you say, okay, let's create a user journey here, right? We sign up for an account, we plan a kickstart, we screen a candidate. This layer is not the needs of a user, those are. But usually, like when we go to a cinema, for instance, we think reserving a seat is an actual need of the customer. It's not. I'm not in need to reserve a seat. I'm in need of going to the cinema and have a good spot in the cinema. And there's a distinct difference here between outcome and output that you want to have your teams know. And this is an anti-pattern as well. We're splitting that big ball of mud based on the objects in the process. So we have an application, we have a reservation, but those are not the objects. What we're looking at is what you can see here, very well explained by Indy Young. If you look at user researchers, they're researching the problems of the users outside your product. So they're looking what's the actual need. Again, as I said, if I go to the cinema, I don't really care that I need to reserve a seat. Well, I care that I sit somewhere on a good spot, but not that I need to reserve a seat. There's a distinct difference. Now, I'm not saying that developers should go all the way there and go do user research, but they should be involved in the user research. They should know what are the actual problems here. And from that user research, products get created. Right? And the products will have their own problems again. Like reserving seats will have their own problems to be solved. But those are not actually the problems of the users. Those are problems because we designed it that way. And that understanding is very important to drive your software design. Because in the end, what we want, and this comes from team topology, what we want in a team is we started with dev, and then we became agile, and then we became DevOps. And DevOps was you build it, you run it. But we missed one thing. It's design. So in team topology, we say a stream-aligned team is a long-term design, build, run for software-enriched services. Usually we skip the design, and usually we put user researchers for the product outside teams. But now you're denying access to relevant knowledge for the teams. And what then happens is that the team gets solutions to build. And that's output driven. And then they're more concerned with, well, how many user points can we do? Or this is not really challenges. Let's create a Kubernetes cluster because that's more fun than just mindfully solving problems. So within team topology, we say, what do we want in the end? We have a purpose and a problem. The team has a value stream, all activities to perform, and then a solution comes out and feedback. And what we need to do in that value stream from a team, we look for blockers to flow. What I see most people do is trying to manage the dependencies they have, but we need to unblock the flow. That's what team topology is essentially about. So that means we need to put design in the team. And this is where collaborative modeling comes in, and this is where I'm writing a book with Evelyn and Gien. And collaborative modeling is a very nice tool. Event storming is a good example. Example mapping, but even user story mapping are good examples of collaborative modeling. They're easy for stakeholders and developers to do and to understand the purpose. So you put stakeholders and a team together and you start visualizing their complex problems. And this creates an opportunity for the developers to also give input into the design. And the stakeholders as well. Because, well, probably we all know software also constrains what we are able to build. And most of the time I see user journeys or user designs being built and like, ta-da! And we're like, oh, look, here's a big ball of mud. Ta-da! unable to rebuild your nice, proper design. It needs to work together. You know? So, a lot of people I teach event storming in, it's very frightening the first time, right? Because you're adding a lot of people into a room. There's a lot of this social dynamics going on here, and that's what actually the book is about. And what we say, first start only with your own team. This is what I did in this client as well. I start with the team itself, give them the knowledge of event storming, and only then add stakeholders to it. I sometimes even just start by myself or tell them, do it for yourself, right? The thing is with this team is that afterwards we moved it to a Miro board, and in the end it became a language for them to talk to. So they went to the Miro board, they say, well, this is what I think we should do. And they used the event storming language. And once the engineers had a good understanding of it, we started doing sessions with the stakeholders. And then it's important to become prepared. But we started with one virtual board and then let the team self-organize around them, right? This is emerging the architecture from this board. Just one board, started designing, and eventually it becomes too big, becomes too slow. Oh, maybe we should split it. If it becomes too slow, maybe we should do something about it. So we can actually split the board. And this was actually a hybrid team, right? But I use it on-site teams as well. It's a lot nicer to move stickies around on a virtual board than it is on this board. So it's a lot simpler for design. And once we started engaging with our stakeholders, we started preparing as well. These are complex problems sometimes, right? So we started creating templates to use with them and create this language together. So from there, we could start distilling bounded context. And we split according to three things. Language ambiguity. Are there two words confusing within the stakeholders? So we had the HR department and the payroll department together, and they used words, but not exactly the same. Okay, split. It's easier to split and give them their own model than to put that into one model. We split according to departments. That's, I hope, a no-brainer. And we split definitely according to the user needs. And those are the stream-aligned teams, the value streams that team topology talks about. It's the user needs. Team topology themselves use user needs mapping, which comes from Wortley mapping. If you never tried it, try to look for it. There's a lot of free things to learn from it. So what we did was start applying domain-driven design and event storming on complicated medium-risk problems. That way we could experiment safely if it's something for us, right? We isolated the problem, we started experimenting in the code. And what happens? Well, it might work or not. And the goal here, or the thing was that most of the times we're so caught up in the solution space as developers or as engineering teams that we miss perspective and understanding and opportunities. That's why really focusing on the user needs is very important. And definitely for a product, put your UX, UI designers in the team. Yeah, they're belonging to the team because else they become a blocker for flow. So, and then I'm going to the last part, which is embedding this all in the software architecture team or architecture in the team. And one insight here as well is they hired me as the software architect, but I never behaved as giving them the solution. I enabled them and I collaborated with them to come up with the solution by themselves. And this is a very important thing. Usually when I go to companies, I see, again, the software architectures outside of the team. Sometimes there's not enough software architecture knowledge in a company, then turn into an enablement team. I don't make decision for the team, I make it with them. There's a very slight difference. And if they want me, I will take the decision, that's fine, but they told me to. Yeah? So if you're as a software architecture outside the team, be sure to start enabling instead of enforcing architectural decisions. And that's really the goal of collaborative software design, is let teams understand their needs, allow this to understanding to shape their software architecture, and this is the essence what we describe in this book. And with that, I created a paradigm shift with them because we could start to experiment. We moved from this model view controller to a more bounded context with event handlers approach. But this was driven by the team. They found books, they found knowledge, and they say, hey, Kenny, look, I found this in our framework. This is usable. And then we started pairing. So I tried, it was Ruby on Rails. I'm not a Ruby on Rails developer. I'm more a Java typed person. So this was horrible for me and for the person I paired with. So it wasn't officially pairing. But in the end, I was with them while they were developing code. And this is also very important. Pair programming, you don't need to pair program all the time, but when new knowledge is popping out or emerging, pair up with the team. This was very natural at some point. They say, when I looked at Slack as well, as the architect there, I saw some ping-ponging chats going on, and I'm like, hey, shall we move to a room? Shall we try to pair this out? And this became natural over time. And that collaboration is very important. And what we used by doing that, and I'm not going into details here, but what I used is create a strategy with them to move from the legacy to bounded context within the same monolith, by the way. So we're not using microservices. We did everything within the same monolith. And I did that with them. And this is also mentioned in the book. This is what we call the bubble context and autonomous bubble context. But the important part is I designed it with them together. I created examples with them together. So concrete examples, how we worked it out in the code, so that the rest of the team then also could start using them. And every time we tried to get a new feature in, we could decide this is a small feature. Yeah, okay, let's build it in. Because, if it doesn't take a lot of time, then do it. But they could decide it for themselves. Oh, this is a longer one, and now we need to move it out. Right? So we enabled the team to make these decisions themselves together with the PO. When do we actually use these strategies, or when do we just build it into the big ball of mud? And that's very important. We gave them the tools, and that enabled them to move further. Now, the other part was, because it scaled a lot, is that there was no software architectural diagram anymore. Who's ever been in a company and doesn't seen any diagrams? Or any updated diagrams? Yeah, so I am a bit... I like diagrams, but they're usually behind on what's there. And a very nice tool that you can use is from a friend of mine, Andrea here. It's called Bite-Sized Architecture Session. I just put them in a room every 2, 3, 4 weeks for 1.5 hours and let them describe their architecture the way they want it. Or they can do it in a C4 model style. That's up to them. And then we merge that together. And this is every 3 weeks, just 1 hour or 1.5 hours. And this is the way that we're building in architecture and the diagrams within the team. And this really helped the team to get a sense of what's actually going on there. So no unnecessary documentation that, let's be honest, always there's one person does the documentation because they care and the rest doesn't care. No, I put them in a room, we model this together. And as you can see in the bottom, over time, it evolved. And it doesn't matter if the first time you get everything, something is already enough, right? Just 1 hour, 1.5 hours every 3-4 weeks was enough. And all this created what we call sustainable design decisions. Because in the end, and people who know socio-technical architecture, most architects sit over here, right? They do architecture on the physical system and the task. The problem is we're living in system, and this is actually system thinking, where also the people and the structure of the organization impact your architecture. So you cannot do that in isolation. And this is also what, for instance, team topology says. They're talking about cognitive load, which is actually here, right? I can design a very pretty architecture or a very pretty design, but if the team cannot handle it, or if the organization cannot handle it, or any of the things, it won't happen. So you need to jointly optimize this together, and you can read more about that in the book. And thank you very much. Do we have time for questions?
Thank you, Kenny. Yes, we do have time for questions. So, any questions? Let's go.
Hey, thanks. It was really interesting. You mentioned a lot when you have multiple teams that need to collaborate. So I'm guessing that it comes with a certain skill. Is it necessarily, or is this only a good idea to do if you have multiple teams, or is it also good to kind of, if you just have a big ball of mud and one team, is it still a good idea to use these practices?
Yes, because the small, I think you can do a finding the bounded context in your big ball of mud is actually already helpful, even if you're with one team, because we had one teammate come in, and within like a week, the person was onboarded and that's the power of DDD. The conversation that we're having around the problem aligned with the code. So they didn't need to do a translation anymore. They're like, oh, they're talking about this problem. Oh, here's the code. Oh, and here are the strategies that we are using with the code. So they could instantly follow it. So I think that that investment is good. Just be careful with where you do it and how much you do it. Within domain-driven design, we don't say we do it everywhere. We do it really where it gets complex. If it's just a CRUD system, nah, I don't think the investment is worth it.
Thanks.
One more over there.
You try like this here.
Yeah, but I'm not sure if it gets recorded. That's the...
Maybe that's for the better. Thanks for the talk. You talked about the role of architecture and architects.
Mm-hmm.
And most of what you talked about is more about sort of the functional design of the system. And also, depending on the type of system, there can also be more technical architecture, which tends to be more shared across teams, and which you have to really have sort of at least all agree on it, or maybe sometimes even dictate what it's like. Can you say a little bit of how to best sort of fill in that role and achieve such a consensus?
So if I get you correctly, it's about are all the teams now independent and are they using the same design principles, right?
Yeah, and also technical architecture. So if you have, nowadays we would probably talk about platform teams.
Yeah, I know. I was just mentioning this is a very hard one because what I usually see platform teams being built, they're usually dictating, and there's a polarity here, right? If you want to do it cheap, we need to all do it the same thing. So I have this heuristic that if you have proper platform groups, the teams want to use your dictated things. If they don't, for you, and that's within team topology, we call that quirky conversations, right? If a team really doesn't want to use your, what they call APIs, right? Or your documentations or your principles, then there's something wrong with it. So you should talk to them. Why isn't this helping you? Why isn't this helping you? So if you do it correctly, they want to actually use you. And that's what you want to create. But I know that sounds easy. No, it's not. But in our book, we talk a lot about conflict management, and I think there's a key there is that we have better, harder conversation because there's usually a conflict that someone is not talking about. Like, yeah, I'm holding on to this because if I don't, I'm not special anymore, and you might fire me. That's the conversation we usually don't dare to talk about, and that's what needs to be talked about. And there are some examples in the book where we do this. Yeah. And I think that's key, having conversation and go into this conflict.
And what about that's when the architecture is already given, right? And you have to sort of sell it. But what about sort of more, let's say, from the start, how do you get to a place where the platform that you're offering is actually suitable for all the teams?
Yeah, so within team topology, we call this collaboration. You go into collaboration modes first. Yeah. So they work together, they pair together, and they become sort of part of the thing. And then one side is building it to solve their business problem. The other side is actually making an API out of it to be reusable for other teams. And within team topology, you also look at the different stages you go through. Similar to what you would do in architecture, right? Different stages. You would do the same with that. And one thing I really like is the team APIs. Make sure what is your API as a team, what are we responsible for, and what do we offer? And as a platform group, you really need to go out there and talk a lot with them. Use a lot of this event storming model with them, but always from a position we want to help you unblock. And not like if you start this, if you start coming in a room and you say, yeah, we just designed this new thing. The first thing they will do is like, yeah, why? Because they didn't ask for help.
Right. Thanks.